Section 4.7 talks about applied optimization problems. So here for the following exercises, set up and evaluate optimization problem. Well, we're trying to construct constructing a cardboard with dimensions 2 by 4 meters. Then you cut equal size squares. So we're going to cut this part out. This, and this. What we're going to do, we're going to fold this up, stand it up, and this fold this up. So this right here will become, and this will be something like that. This side right here will become this box, this part of the box, and this part right here will become this part of the box. Now, when I pull this up, that's going to be the height of this box. So this height will be x, which is that right there. Now, if this is 4 meters, and I chopped an x out of this side and an x out of this side, then this piece remaining inside would be 4 minus the 2x. And if I was to take this piece right here, the whole thing is 2. If I chopped an x out of the top and an x out of the bottom, then this inside will be this, and that's 2 minus 2x. Now you should know that if the whole thing is 2 meters, I can't cut more than 1 meter from each side. So x has a limitation. X cannot be bigger than 1. Actually, it can't even be 1. It has to be less than 1. Now, what they want me to do, and you have to read the question to figure out what it is you're trying to maximize or minimize. It says, what are the dimensions? They want the dimensions. They want the length, the width, and the height. What are the dimensions in meters, of course, of the box with the largest volume? Well, largest volume, that's a maximum volume. I'm going to find an expression for volume, and I'm going to take a derivative of volume and do the testing and figure out where you have a minimum or a maximum. In this case, they want a maximum. Well, the volume of a prism is area of the base times the height, or simply length times width times height. I could factor a 2 out of this and a 2 out of this. Not that it's going to matter because I'm going to have to multiply those out. If I FOIL those, I'll get 8 minus 8x minus 4x plus 4x squared. So basically the volume is 4x cubed negative 12x times x negative 12x squared plus 8x. There's my volume. So the hard part in this section is coming up with the equation. Once you get the equation, well, we know what to do. Take a derivative. That's 12x squared minus 24x plus 8. And now I'm going to check, where does that derivative equal 0? It exists everywhere. Well, I'm looking at, if I factor a 4 out of that, that's 3x squared minus 6x plus 2 equals 0. No factors of 3 times 2, that adds up to either a 5 or a 7, so that doesn't factor. Well, I'm going to choose completing the square. So I'm going to take x squared, divide each of those by 3, minus 2x plus a number equals negative 2/3 plus a number. Take half of the middle number, which is 1, and square it. So I'm looking at x minus 1 squared equaling over 3. That's a 3 over 3. 3 minus 2 is 1/3. Square root both sides. I'll get plus or minus 1 over radical 3. And x will be 1 plus or minus 1 divided by radical 3. Radical 3 is about 1.7. So 1 divided by 1.7. Basically, it's about 1 plus cannot work. It has to be 1 minus 1 divided by radical 3. Like we said, if this side is 2, you can't cut more than 1. So 1 minus 1, so this is roughly about 0.4, about, or 0.5, something like that. Well, if I do the testing, I'm going to take 1 minus 1 over radical 3. there is f prime, there's f. I pick a point to the left of that. Let's say I pick, for testing purposes, I could pick 0. If I put 0 in there, that will be positive. And if I pick a point to the right of that, say 1. And if I put 1, 3 plus 2 is 5, minus 6, that's negative. So we have a maximum volume. Now here they want the dimensions. You could find the maximum volume by multiplying length times width times height. I have a maximum volume for, now the length is, x is 1 over 1 minus, now of course you could use decimal if you have a calculator, right? And let me check, what would that be? If you allow a calculator, you simply take 1 minus 1 divided by radical 3, 0.4. So you could say that's 0.4. So you use 0.4, and the units were in meters, by, I'll go up there. If I take 4 minus 2 times 0.4, that's roughly 4 minus 0.8, that's about 3.2. And if I take 2 minus 0.8, that will be 1.2. So I could say it is 0.4 by 3.2 by 1.2 meters. Again, they want the dimensions. That'll do. And if they want the volume, you multiply those out, and it gives you the maximum volume. If you want to use the actual numbers, you could say that's 4 minus 2 times 1 minus 1 over radical 3. So that's 4 minus 2 plus 2 over radical 3, 2 plus 2 over radical 3. Those are meters, and the height would be 2 minus 2 times 1 minus over radical 3, the same as those. That will be 2 minus 2 plus 2 over radical 3. Those cancel out, and you're left with 2 divided by radical 3 meters. So if you're not allowed a calculator, that's what you write. If you're allowed a calculator, there it is. Here's another problem. Find me the sum of two positive integers such that their sum is 10. If you take two positive integers, let's say x and y are both positive, their sum is 10, and minimize and maximize the sum of their squares, the sum of their squares. Now what's wrong with that? There are two unknowns. So if I solve for y, I say y equal 10 minus x, take this and put it right there. And now this sum is in terms of one unknown. And now I could say, well, to minimize or maximize a sum, take its derivative. That's 2x plus 2 into 10 minus x to the 1 times derivative of the inside by the chain rule. So the derivative is 2x minus 2 times 10 is minus 20, and minus 2 times plus 2x. S prime will equal 4x minus 20. Now if I take s prime equal to 0, I'll get 4x minus 20 equal to 0, or x equal 5. I'll do my testing. There's the sum prime and there's the sum. Pick a point to the left, say 1. If you put 1 in there, you'll get 4 minus 20, which is negative. If you take 6 and put it in there, 24 minus 4 is positive. So we have a minimum sum when x equal 5, and if I put 5 in there, y equal 5. So 5 and 5 will give you the smallest. Now, since this is always decreasing, either the left endpoint or the right endpoint will give you the maximum. Maximum sum, well, what's the smallest positive integer you could choose? Is in the left. 1 would be the smallest. If y equal 1, if x equal 1, y would be 9. And that's how it works. Now check. If you put 5 in there and 5 in there, that's 50. And if you put 1 in there and 9 in there, 81 plus 2 is 82. That's the largest sum of squares you can get out of those. Get to the next problem. Consider the construction of a pen to enclose an area. Well, these pens are rectangular in nature. So in this problem, here's a rectangle. Again, it's important to figure out what is it you're maximizing or minimizing. Anything that I'm maximizing or minimizing, I take a derivative and set it equal to 0. The point is, to come up with the equation, I need it to be in terms of one unknown. You have 800 feet of fencing. Now, if the units are linear, that's perimeter. If the units are squared, that's area. And if the units are cubed, that's volume. The perimeter is 800 feet of fencing. That's what we have to make the pen. If you have a river on one side of your property, let's say you have a river right there, which means you don't have to fence the riverside. What is the dimensions of the rectangular pen that maximizes the area? I want to maximize an area. Now, you could use length times width if you wish. You could use x and y. I'm going to stick with x and y because that's how the book uses. If this is x, and this is y, you could call this w, and length. It doesn't matter. So, area is obviously this area is length times width. It's xy. We have two unknowns. I want to get rid of one of those. Since we always deal with x, I want to get rid of y. Now, how am I going to do that? That's where this other piece of information comes in. The perimeter is the sum of the surrounding. Remember, I'm not enclosing this side because there's a river. So the perimeter will be x plus x, which is 2x plus y, and that's 800. So if I want to eliminate y out of the equation, I'll solve for y, and I'll get y to equal 800 minus 2x. So now, if I put that in there, I have my area, negative 2x squared plus 800x. Well, here, I have it in terms of one unknown. Once I get the equation, which is the hard part of the problem, I know what to do. I take a derivative, negative 4x plus 800. Where does that equal 0? When x equal 800 divided by 4, that's 200. I'll do my testing to ensure. There's 200, there's a prime, and there's a. If I pick a point to the left of 200, say 1, negative 4 plus 800 is positive. And if I pick a point to the right of 200, say 201, that will be 804 negative plus 800, that's negative 4. So we have a maximum area. Now, do they want the maximum area or the dimensions? If you look at the problem, it says, what is the dimension of the rectangle? They want the dimensions. Maximum area when the length is 200 feet and the width is, if I put 200 in there, that's 400, 800 minus, that's 400 feet. And if they say what's the area, you multiply those. Or you could simply say maximum area when you have 200 feet by 400 feet. That's normally how we write dimensions. So again, coming up with the equation turns out to be the challenge. Once you get the equation, we all know what to do. Here's another problem. A patient's pulse measured by 70 beats per minute, 80 beats per minute, then 120 beats per minute. It's increasing. To determine an accurate measure of the pulse, the doctor wants to know what value minimizes this expression, call it E. So this expression, how do you come up with that equation? They gave it to us, so not an issue for now. But how do you find, they're asking, wants to know what values will minimize it, the expression. Well, if the expression is x minus 70 squared plus x minus 80 squared plus x minus 120 squared, if I want to minimize that, I'll take a derivative of that expression. That's 2 into x minus 70 plus 2 into x minus 80 plus 2 into x minus 120, and I'll set it equal to 0. 2x minus 140 plus 2x minus 160. plus 2x minus 240 equals 0. 2, 4, 6x. Now we have negative 140, negative 300, negative 540 equals 0. Where does that happen? When x equal 540 divided by 6, which is 90 beats per minute. And just to ensure that that's how it works, there is the derivative and there's the expression. If I pick a point to the left of the 90, let's say 1, I'll get 6 minus 540, that's 0. A point to the right, say 100, 600 minus 40 is positive, and that tells me it is we have a minimum of that expression. What value minimizes the expression? 90 beats per minute will minimize it. Or you could say the expression will have a minimum value when we have 90 beats per minute. So if I have an equation, it's an easy problem. If I don't have an equation, I have to come up with it. The last problem in this section that we have, you are building 5 identical pins adjacent to other with a total area of 1,000 meters squared. So the area is 1,000 meters squared. As shown in the figure, what dimensions should you use to minimize the fencing? The fencing would be the perimeter. Now, if I look at this, I am going to put a y right there, another y, another y, another y, another y, and another y. I'm going to put an x, 2, 3, 4, 5, 6, 7, 8, 9. There are 10x plus 1, 2, 3, 4, 5, 6y. That's how much I'm going to fence. I need to get rid of one of those. I want to get rid of the y because we're so used to x. And isn't the area of this, let's see, we said that was 5x. Area is 5x times y equal 1,000. So isn't y 1,000 divided by 5x or 200 divided by x? Take that value and put it right there. And that becomes 200 over x. So I could say the perimeter is 10x plus 1200 x to the negative 1. Now what do we do with that? Well, the tradition, we take a derivative. That's 10 minus 1200 x to the negative 2, or simply the derivative is 10 minus 1200 divided by x squared. The perimeter is 10x squared minus 1200 divided by x squared. I'm going to do my testing. P prime equals 0 when 10x squared minus 1200 equals 0, or simply x squared equal 1200 divided by 10, 120. X is the square root of 120. Now, denominator equals 0 is useless because they say if you want to make the smallest pence or minimize it, just don't make it. That's what 0 means. Now, to ensure that this is matching what I'm assuming, there's this change of rate parameter, there's perimeter. Pick a point to the left of the square root of 120. If I pick 1, denominator is always positive. If I put 1 in there, 10 minus 1200 is negative. And if I pick a point to the right of square root of 120, let's say 10. 10 squared is 100 times 10, that's 1,000. 10, this is bigger than square root of 100. Let's say 15. 15 squared is 225 times 10, that's 2250. Minus 1200 is positive. So we have a minimum perimeter. And do they want the smallest perimeter or the dimensions? What are the dimensions? We have minimum perimeter when x is square root of 120, and that is in, what is that, feet? Meters. And y would be 200 divided by square root of 120. Now I could reduce that a bit, I could clean that up, but that's good enough. You really don't have to worry about that. And if they say what is the perimeter, you plug in square root of 120 in there, 200 over square root 200 in there, and that'll work. Now I do want to point out for your homework, we want to talk about a cylinder really quick. If we're talking about a right cylinder, you need to know that the volume is area at the base times the height. If you want to talk about surface area, if it's closed, it's going to be area at the base, which is a circle, and there's two of them, the base and the top. Plus, if you take this piece and you cut it with a laser right there and spread it out, it's going to look like this, where the height of that is h, and the length of that is really the surrounding of this circle. The surrounding of a circle is 2 pi r. And if you want to find the area of that, that's simply length times width. And there's the surface area. And that takes care of this section as well. I wanted to do the following example so I could help you out with the homework. Again, the homework is right there. But we want to do one more problem. Find the volume of the largest right circular cylinder that fits inside of a sphere of radius 2. So we have this cylinder. We want to fit this cylinder in a sphere, something like this. Radius is r, that's h. The radius of the cylinder the sphere happened to be a 2. Well, if we want to maximize the volume is area at the base times the height. The issue with that, there are two unknowns. We need to get rid of one of them. And here's where we're going to improvise and say, look, if this is 2, then this is 2. If this is r, then this is r. So I'm really looking at the height. This is 4 and this is 2r. And if I take that squared, 16 equals h squared plus 4r squared. Now I have a couple of options. I could solve this for h, I could solve this for r, and I want to show you the difference. If you decided to solve this one for h, then you're saying 16 minus 4r squared equal h squared, and h equal the square root of 16 minus 4r squared. And if you decided to solve this for r, you're saying 4r squared equals 16 minus h squared, and r squared equals 16 minus h squared divided by 4. Now watch what kind of equations I'll get. If I decided to replace r by what I got, versus if I decided to replace h by what I got. If I decided to replace r by what I got, then I'm really going to replace r squared with simply (16 minus h squared over 4). And I'm saying v equal pi over 4 times 16h minus h cubed. Versus if I decided to replace h, and those two will give the same result. If I put a square root of 16 minus 4r squared, I'm looking at pi times r squared, the square root of 16 minus 4r squared. And of course, you could see the derivative here is a lot more work than this. So if I take v prime here, that's pi over 4 times. Derivative of this is 16 minus 3h squared. That's a lot nicer to work with than this radical. They both give the same result. Why not just go with the simpler? Where does that equal 0? Well, multiply by 4 over pi both sides. You're looking at really 16 minus 3h squared equals 0, or simply h squared equals 16 over 3, and h will equal 4 divided by radical 3. If h equal 4 divided by radical 3, if I pick a point to the left, let's say I pick 1 and put it in there. 16 minus 3 is positive. And if I go to the right of 4 divided by radical 3, let's say I pick 4. 4 squared is 16 times 3, that's 48, that's negative. So I have a maximum volume. Do they want to find the volume or the dimensions? Find the volume of the largest circular cylinder that fits. Okay, so you want the actual volume. Well, keep in mind, if I took this route, I have the h, and I know that the radius squared will be 16 minus, if I square that, 16 over 3 over 4, that's a complex fraction. LCD is 3, and r squared will equal 48 minus 16 is 32 divided by 12, that reduces, divide by 4, that's 8/3, and r will equal the square root of that. And the volume would be basically pi r squared h. So the volume will be maximum volume will be pi times the radius squared. The radius squared was 32 over 3. No, 8 over 3. If you square it, times 4 over radical 3, and that will be 32 pi divided by 3 radical 3. And the units will be, if they didn't give us the units. And that's going to help you with the problem on your homework. And now that concludes that section.